Good morning, class. This is Miss R, and I wanted to welcome you to your first online lesson. I know this is going to be probably strange for you at first, but I think you'll get the hang of it as we go. Each day, I'm going to take the lesson from the lesson that we're taking a look at, and I'm going to provide you a blank copy that you can print off on the website, as well as I will do a video where I complete it in, and you can fill the answers in as you go. And please come and see me if you have any questions that you didn't understand during the lesson. Maybe star something if you didn't quite understand it as I go through the lesson, and I can explain that with you in class. By all means, we aren't expecting you to master the topics at home when you're watching these videos. It's going to take some time, ladies and gentlemen, for you to practice some questions. Remember, math isn't just a participation course. You need, or isn't just a spectator course, I should say. You need to participate. Doing the questions will help you develop a better understanding of the key concepts. And I'm here for extra help. Remember, we've got math and science help on Tuesdays, as well as just come see me, and we'll work out an appropriate time if you want some one-on-one help. All right, so let's get started. And again, some of these lessons, ladies and gentlemen, are going to be short and sweet. Some of them are going to be longer depending on the difficulty of the topic of each lesson. Okay, so most of this should be a review with some new parts thrown in the end with some definitions. All right, so let's take a look at what we can remember from grade 10. All right, so let's get started. Today's lesson is 1.0b, Getting Started, Review of Lines and Parabolas. And what you will notice, folks, is these tend to go in order, and I try to have them to match your textbook as much as possible, and they should go in numerical order. All right, let's get started, ladies and gentlemen. So the first thing main thing that we talked about in grade 9 was lines and linear lines. When we take a look at a linear line, the slope y-intercept form of the line is y equals mx plus b. Okay, so hopefully you can remember that. And there is two key parts that we should remember. We should remember that the m is the slope, or the rate of change. If you remember from word problems, that was the rate. If you got paid $5.50 an hour, that's where you would put that. And the B part, ladies and gentlemen, is what we call the y-intercept. That is where it crosses, the line crosses the y-intercept. Or if you're talking about word problems, that's the initial or base fee. Okay, all right. So that's the equation of the line for the slope y-intersects form. Okay, you could also have standard form. By curiosity, if you want to know what standard form is, I'll put it up in the corner here. It's ax plus by plus c equals 0. So that's what we call standard form. And we got used to switching them from one form to another last year. All right, let's take a look at the next thing. Finding slope of AB. So when you're given 2 points, just remember point A is like the first point, so that's why you go x1, y1, whereas point B is the second point, so that's why it's called x2, y2. And remember, your ordered pair is always x then y, so it goes in alphabetical order. So if you're looking for the slope formula for that, ladies and gentlemen, slope in this case of AB equals y2 subtract y1 over x2 subtract x1. If you want to relate that to other formulas that we've taken a look, just remember, guys, that that also equals the rise over the run. And if you're looking at a table of values, that's the change in y over the change in x. So we had 3 formulas that we used, and I'll identify when to use each one. So the first one we take a look at is when you've got 2 ordered pairs. Okay. The second one, ladies and gentlemen, is when you have a triangle or a graph. Okay. And the third one is when you've got a table of values. In my class, I like to use some short forms. So table of values is going to be T of V. Okay, T of V, table of values. All right, let's practice some of these questions, ladies and gentlemen. Let's practice doing some of this. All right, step 1, graph these 2 equations. So A, says to graph. Well, first of all, I look at what form it's in. It's in the slope y-intercept form. So what two things do I know? Automatically, I know my b equals 5. So on my graph, I'm going to plot that. B equals 5. Okay, then I take a look at my slope. My slope equals -2/3. Always put the negative up top, ladies and gentlemen. Normally you rise and fall. Sorry, normally it's rise over run, but in this case it's negative, so you're going to fall and then run. So hopefully you remember this patterning. So what I'm going to do is I'm going to go to my y-intercept right here, and I'm going to fall 2 and run 3. Do the same thing again. Fall 2. Run 3, do it one more time, fall 2, run 3, and then we can draw a nice line with that, with your ruler, ladies and gentlemen, okay? I'm just going to color it up, hopefully, put some properties on it. I got to make sure everything has a start arrow and end arrow, and we'll mark that one as blue. Okay. There. Any questions with that one? And you either identify it with A or write the equation beside it. All right, let's take a look at B. I'll do B in red, ladies and gentlemen. There's a couple ways you could solve this. First of all, you could create a table of values, sub in x, find y. You could rearrange it into the form y equals mx plus b. Or what I'm going to use in this case for B, I'm going to use x and y intercepts because I find that's the easier method when it's displayed in this manner. Those are the three methods you can graph. Table of values, slope y-intercept method like we did up top, and this is going to be x and y intercepts. That's what we're going to do for this one. I'll just put down here slope y-intercept method. All right. So to find your x-intercept, ladies and gentlemen, you should remember this from last year, but if you don't, that's okay. To find your x-intercept, we let y equal 0. So we rewrite this equation. Wherever we see a y, we put a 0. 0 times anything is 0. So we have 4x equals 12. To get x by itself, divide both sides by what's in front of x, or currently being multiplied. So you got x equals 3. So on the x-axis, ladies and gentlemen, plot 3, because that's what that is. Okay, now let's find the y-intercept. So to find the y-intercept, we're going to let x equal 0. So it's going to be 4 times 0 plus 2y equals 12. Okay, again, 0 times anything is 0, so you're left with 2y equals 12. To get y by itself, you divide by both sides by 2, so y equals 6. So these are the two things, the x and the y-intercept, that we use to draw a line. So what we're going to do is take a look, y equals 6, which is right here, and then we're going to draw a graph. Sorry, draw a line. Okay, mine's just a tinge off. Hopefully you can use a ruler and just get it a little more accurate. There we go. And then let's add some color to it so it looks like it matches what we're taking a look, and that it starts and it ends with an arrow. Okay, and label it B. All right. So there's your two linear graphs. Those are straight lines. Then we spent a lot of time with quadratic functions. And these are what looks like a parabola on the graph. Okay? So just remember, ladies and gentlemen, it can open up and have what we call a minimum. Or it can open upside down or flip or reflect the x-axis is what we're going to say. And it's going to have a maximum value. All right? So let's take a look at what we can remember from grade 10. First of all, we had the vertex form, which is y equals a, bracket x minus p, bracket squared plus q. And remember, in this case, the vertex was p and q. In this textbook and in grade 11, we're going to change it to function notation, so we're going to use different letters. So we're going to start off with y equals a bracket x minus h squared plus k. So the only difference here is instead of p and q for a vertex, you're going to have h and k. All right, the a stays exactly the same, and let's deal with a. Okay, a tells us that we have what's called a vertical stretch or compression, and this is stuff that you're going to know for your final exam. Believe it or not, I'm telling you stuff on first day that's going to be on your final exam, which is on your last day. Okay, and vertical stretch is when you've got the absolute value of a. We're going to go over what absolute value means in a second. Okay, is greater than 1. That means you're stretching it. Whereas if it's compression, absolute value of a is less than 1. Okay, then it also tells you the direction of opening. Okay, if a is greater than 0, it's going to open up. Whereas if a is less than 0, it's going to reflect the x-axis. It's going to open down. Okay. You may also remember, ladies and gentlemen, the step pattern from grade 10. A times 1, 3, 5. And that's tied into this vertical stretch or compression. All right. P in this case tells us our transformations that we shift left or right. So that's your horizontal movement. So we'll call that horizontal translations. Okay. And if P is greater than 0, we move to the right. Okay. Remember, the formula is negative, so what that looks like for an example, hopefully you remember it's the opposite. That tells us to go right 2. All right. Whereas if P is less than 0, we're going to move left. Let's change that example up. So let's say x plus 5. Remember, how did the formula, which has a negative up here, suddenly become positive? It had to be multiplied by a negative. So that tells us we go left 5. All right. Now, Q, which is the last one, instead of our moving left-right, we're going to move up-down. And we call that our vertical translation. Okay. What does that tell us? If Q is greater than 0, it moves up. And if Q is less than 0, it moves down. All right. So any questions about that? We will be adding on another type of horizontal stretch and compression. That's the letter K, but we'll get to that in a little while, so I don't want you to worry about it. But we are adding on from the quadratics from grade 9. And then we'll be applying it to all different functions, not just quadratics. Okay, and we're just going to recall the step pattern, which I mentioned up top. A times 1, 3, 5. Okay, so if A what you basically do from the parabola vertex, you go over 1, and then you go up 1 times whatever A is. And then again, from there you go over 1, up whatever 3 times A value is, and over 1 and up 5 times A. If you're not sure about this step pattern, if your teacher didn't tell you in grade 10, we'll go over it together. Let me know. All right, most teachers teach that step pattern: over 1, up 1, over 1, up 3, over 1, up 5. Okay, now we're ready to do a question here. Example 2, state the transformations to y equals x squared, and then graph this equation. So first of all, I like to write down my formula right above it. Okay. Well, first of all, let's draw the base parabola. Okay. So this is called the parent function. We're going to learn a definition about that in just next page. Okay, so the parent function is, that's the starting block before we shift things left, right, up, down. Okay, so let's start by graphing the parent function. Remember, the parent function starts at the origin, and we do that step pattern. And because it's the most basic parabola, a equals 1. So you go over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 1, 2, 3, 4, 5. Because it's symmetrical, you do the same on the other side. Over 1, up 1, over 1, up 3, over 1, up 5. So this is what we call the base or parent function. Okay, and now I'm going to change colors to do the transformation here. What might be helpful is if we rewrite our standard, our formula that we've learned from grade 10, and we'll stick with the P and Q until we get to the H and K, just for people who should remember this. So based on that, ladies and gentlemen, what should we know? We know that A equals -1/2. Okay, we should know that P equals -3 because the formula went from being negative to positive. And we should know that Q equals 7. That's great. That's stating the letters, but to tell the transformations, you've got to describe what each of them means. So first of all, we should note for A that we have a negative, so it opens down. And we're going to call that reflects the x-axis later on. Okay, let's actually put that in so we recognize that terminology. So it reflects the x-axis, and since it's a half, that means it's going to be wider by a factor of 0.5. Okay, so instead of having a step pattern of 1, 3, 5, it's going to be 1/2, 3/2, 5/2. It's going to be wider. Okay, and what else does it tell us? It tells us P tells us that we are going to shift left 3, and Q tells us we're going to go up 7. So how do I graph this, ladies and gentlemen? I first of all say, what do I know? I know my vertex is -3 and 7, which is my P and Q, right? If you're not sure. So vertex PQ equals the vertex. So let's plot that. So -3 and 7 is here. Okay. And then from that, I'm going to use my step pattern. Okay. So step pattern is A times 1, 3, 5. In this case, A is -1/2 times 1 times 3 times 5. So what does that equal? -1/2, -3/2, and -5/2. That's what our step pattern is. Or some of you may like decimals in this case. It might be easier. You may like -0.5, -1.5, and -2.5. All right, so let's take a look. We already plotted our vertex, so we're going to use that step pattern from there. So as I go over 1, I'm going to go down 1/2 on each side. Okay, as I go over 1, I'm going to go down 1.5. And as I go over 1, I'm going to go down 2.5. All right, and then I'm just going to draw my curve as best as you can. Your parabola doesn't need to be perfect, okay? And then again, I'm going to put my equation down. Y equals -1/2 x plus 3 squared plus 7. Now, I know that was a big jump, ladies and gentlemen, from what I expect you to read. Remember from grade 10, if you need some help with quadratics, look in the appendix section, and there's quite a good review on that as well. All right, next page. So taking a look, just to finish this off, we have some definitions that you need to be aware of. So first of all, a parent function is the simplest form of a function. It's also called the base function. So for example, you should recognize this as a quadratic because it's got x squared and it's in vertex form. So the parent function or the base function here is what we discussed on the last page, y equals x squared. That means you take away the A, you take away the P, you take away the Q. You take away any of those shifts, left, right, up, down, flip, reflect, stretch, compress. You take away all those, and you're left with your parent or base function. The second thing we want to talk about is absolute value. Okay, and it's written like this. The absolute value of x describes the distance from of x from 0. Okay, what it means is to make it positive. So in that last example, ladies and gentlemen, remember a equals -1/2. The absolute value of a equals the absolute value of -1/2, which equals, make it positive, 1/2. Okay? Basically, ladies and gentlemen, when you think about it, when you're dealing with A, the negative part tells you to flip it or reflect the x-axis, and the half part tells you the step pattern, okay, or how to make it more, wider. Okay, so that's why we deal with absolute value signs. So the absolute value of -8, ladies and gentlemen, is 8, and if it's positive, you leave it positive. Okay. All right, so one other example I want to throw in here just to make sure we're okay. Just remember, ladies and gentlemen, if you take the square root of 25, that can be what? Plus or minus 5. However, if I asked you for the absolute value of root 25, there's only going to be one positive answer, and that's going to equal 5. So that's one way to remember it, is that you always take the positive value if you're taking a root. All right. And the last thing that you probably have heard of, and it's got a funny spelling, ladies and gentlemen, it's called an asymptote. An asymptote is a line that a graph of a relation gets closer and closer to, but never touches or crosses. And remember, guys, it's the dotted line on the graphs. It's not the blue line. That's the relation. So the blue in this case is what we call the relation. In that case, that's a hyperbola. Okay. Whereas the red part, or red dashed line here, is your asymptote. Okay. Most commonly, ladies and gentlemen, when we deal with exponential functions, this is where you've got a curve coming down. This is an example of a increasing function. So it starts very, very close, and this is an asymptote. Okay, and again, if you want to Google that information to find out, there are many different funky types of asymptotes. Okay. All right, ladies and gentlemen, we have now completed our first lesson. Hopefully everything went okay, and if you need some help, please come and see me. Here's today's homework, and I'll always post it at the end, ladies and gentlemen, in a box. And today's homework is page 2, number 4, 6, and 7. And as always, and I'll probably say this most days, if you need any help, please come and see me. And I also want to wish you a great day and happy good start to the next semester. Thank you and have a good day.